In this video, we're going to cover some looping structures. For example, if we have a 3-year-old simulator program, like so it's a simple simulates a conversation with a three-year-old child, like toddler, right? So why why? I don't know why. So this is a kind of like a looping, constant looping of this. um, it's pretty funny, right? Kind of. So what we're using is actually a while loop. The while loop, the basic structure will be a while is a keyword, and then you have condition, and then you have the block. When the condition is true, then the block will be executing. When the condition is false, the block will not be executing, will be skipped. So for example, while response is not because, then the response will be basically whatever the input is. We'll simply just ask why, and then take the input of the user's input, right? Take the input, and then that'll be our new responses. So we can repeat the repetition based on the condition, right? Um, so um, here is for the while loop. We gotta be careful because the the variable used in the loop condition, it's called the entry variable, right? It's called the entry variable, and the loop body actually is a block associated with the loop. It can have multiple lines. In the example, we only showed just the one line, and this one can be an infinity loop, that a loop will never ends. It considered as a logical error in some cases, but there are some applications they want some infinity loop. For example, if we are writing a server program, like we expect our server be available forever. So in that case, we will have to use a infinity loop. And how do we fix an infinite loop? We can use a variable to control the steps, to control how many times the loop will execute by using a variable. For example, if the health, we can damage the health. We can reduce the value of the health. When the health eventually reach to 0, then the loop will actually be finished, right? Create an intentional infinite loop. Sometimes we need intentional infinite loop. We can simply put the condition as a true. So in that way, it will continue run. And sometimes we want to break a loop. For example, if we're looking for a particular value in a list of values, or in a sequence of value, if we found the value, we can simply just break the whole loop. We don't have to waste the computing cycles. So for example, this one, it says while true, so it's an intentional infinity loop, and the count plus equals to 1 means count equals to count plus 1. So if the count is greater than 10, then it's break. So that means the count can go up to 10, right? Not included 10. So it's up. It will at most be 9 if the count is an integer. So that's how do we do the break. So once the break is executed, it will never go back to the top of the loop. It will simply just kill the whole loop. Continue, however, is different. Continue means if I have the condition meet here, if the condition is number 5, then I simply just skip this whatever the 9 is down here. We simply just go back to the top of the loop. We starting to do the count again. So that's the difference between count and continue. And then we can also use the for loop. A for loop is another type of loop, like a while loop. However, it's you are going to have a control of the for loop. For example, for loop can use for I in the range of 10. Range of 10 is actually give you a list of numbers, and then you are going to go visit each of those numbers. This is another example. Suppose I have 3 numbers. I have a range of 5s. So starting from 0, and the increase step is 5. So 0 plus 5 will be the next one. We can continue doing this one, like the range of this will be 0, 5, 10, 15, 20, 25, and so on up to 50, right? So we simply just print out the I, and then we can count backwards. We can starting from 10, ends at 0, and the step is actually -1. So we are going to -1, right? We're going to starting from 10. The next one will be 10 minus 1. That will be actually 9. Next one will be 8. Next one will be 7. So we print the i's. To understand the for loop, so first of all, it's actually a sequence. So it's an ordered list of elements, and then the elements are actually, each element is a single item in the sequence. It's also iterates. It moves through the sequence from beginning to the end, from the very first to the end. So with those basic knowledge, we can actually make a simple game. It's called Guess My Number. So the computer will first randomly generate one number, and then you will be asked to guess a number between 1 to 100. So when you guess a number, it's gonna give you indicator it's going lower or higher. Eventually you're gonna guess it, right? Then it tells you how many times you tried. You can write this kind of program with what we have learned. The generate a random number. So to generate a random number, you will have to import a random model. A model is actually a set of code that has written by other people. You can directly use. It's like a library. So it's keep in mind those random number are actually pseudo random. It's generated by a formula. It's very complex, but it's a kind of a predictable pattern, and it can repeat it with a same seed number. If I give you a exactly same seed number, then the random number actually will repeat every time you run the program. It's actually a sequence of the number, right? So range function generates random numbers from a range. If you pass a single integer n, the random range is gonna returns a random number from 0 to n minus 1. A random range is actually part of the random model. The model is actually files that contains the code and has been written by the expert of that aspect. Random is like a toolbox. Okay, range is like a tool in a toolbox. A random is a much bigger connection. A range is smaller connection of random. So range function will actually, when you want to use it, you will have to import random. now you can actually access the rand range via the random package or model. Um, so this is the example, right? This example we just showed. The last part we're going to mention is about the programming planning. When you want to do a program, you will first make a good plan, just like you want to go to a trip, or you want to go fishing, you want to go camp. You will first make a plan, how do you make the whole thing, make the whole task finished efficiently. Same thing when we do programs. Programs basically is a set of instruction to finish a task. It's similar to what you're planning. So when we have a good program planning, it will save the time for the future. So sometimes it's called the program designing. So we design first and then implement the program and then test it. So we will have to design the algorithm. We have to do the stepwise refinement, and then we can write the pseudonym to verify that the plan is sound. So what's a pseudonym, pseudocode then? When we write a pseudocode, so pseudocode is basically outline of the program right in English that we can understand. Here is an example of the pseudocode. For example, we have a pseudocode like if you can think of the new and useful product, then that's your product. Otherwise, it's repackaging the existing product as your product, and make a then make information about your product and show the infomercial on the TV, and charge 100 per units of your product. Sell your 10,000 units of your product. So you will notice that all of those are actually pure English. However, it helps you to examine the logic, examine the algorithm. So you can apply the stepwise refinement to actually go more details. For example, create a infomercial about your product becomes like write a script and then rent a TV studio and hire a production crew and hire a enthusiastic audience and film the infomercial, right? Those are the stepwise refinement, and eventually you can have the whole program be done. So it's like follow the philosophy divide and conquer. You have a big task, however you break it down into smaller tasks, and then you further doing the stepwise refinement and even break the subtask into subtasks, right? So that's the basic philosophy, divide and conquer. In this chapter, what we covered is basically include the two types. One is branching, the other one is called a loop. With the branching and loop, you pretty much can write some simple programs now, and we also will stand on the shoulders of the giants. We can use other people's models, which will be counted as package or the libraries. Model, to import a model is very simple. Just you tap import and then the model name. Sometimes when the model is too big, we don't want to import the whole model. We can just import a particular methods or functions of a model. That is doable too, but we will go to the details in the future. That's what we have for now.